Find the derivative of the square root of x squared y squared plus 4 equals 3y squared minus x plus 2x cubed y. We have an implicit equation here. We have x and y related to each other, though it is not solved for y in terms of x, and it's not possible to solve for y in terms of x, so we will have to take the derivative implicitly. Before we do that, let's rewrite the left side as a fractional exponent. We have x squared y squared plus 4 to the first power second root. And then this is equal to the right side, which I will leave as is. To find the derivative implicitly, we take the derivative of both sides with respect to x. I will indicate that by a prime on both sides. On the left side, it starts as a power rule. Bring the power down. Leave the inside alone. Subtract 1 from the power. I will call it 2 halves. And then multiply by the derivative of the inside to complete the chain rule. The first term on the inside is a product, x squared times y squared. The derivative of the first, 2x, times the second left alone, y squared, plus the first left alone, x squared, times the derivative of the second, 2y, and then times y prime to complete the chain rule for that term. Every time we take the derivative of a y term, we have a y prime multiplying it due to the chain rule. The derivative of the 4 is a 0. Equals to, the first term will be a power rule. Bring the power down, subtract 1 from it, and then multiply by y prime to complete the chain rule. The derivative of minus x is minus 1. And then the third term on the right is a product rule. The derivative of 2x cubed will be 6x squared times the y left alone, plus 2x cubed times the derivative of y, which will be 1 y prime. On the left side, this quantity is to the power 1 minus 2 negative 1 half power. And I can factor a 2 out of what's inside of the parentheses for the other part of the left side. And if we factor a 2 out, it comes out of both terms. The point of bringing that 2 out is that 2 and the 1 half can multiply and cancel to become a 1, just to simplify it down a little bit. The right side I will leave as is. The next step, I can move that negative exponent to the denominator. And it can then be a positive exponent. So it'll be x squared y squared plus 4 to the positive 1 half. I will leave the right side alone. In the next step, I'm going to rename the positive 1 half power in the denominator as the square root. It's customary to put it under a radical, in the case when it's a 1 half power, to rename it square root. Again, leave the right side alone. All right, in the next step, I'm now going to take this square root and multiply it to the other side and distribute it to each of those terms. That removes the fractions because we no longer have a denominator. And so I'll write it before being distributed in. And now we can distribute it in. So we have x y squared plus x squared y prime equals 2. So if we distribute on the first term, the 6y and y prime can all stay out front, and then multiplied with the square root. The minus 1 can stay out front, the 1's implied, and then the same square root. The 6x squared y can stay out front, the same square root, and the 2x cubed y prime can stay out front, and once again the same square root. The reason we would want to do this is we need to isolate the y prime terms. There's a total of 3 of them. We have this one here, we have this one here, and we have this one here. We need to put those together on one side. I'm going to opt to put them on the right side. 2 of them are already over there. We're going to move the third one over. All the terms that do not have a y prime are going to move to the left side. On the left side, we already have the xy squared. We're going to add over a square root of x squared y squared plus 4. And we're going to subtract over a 6x squared y times the square root of x squared y squared plus 4. On the right side, I will have the 2 terms that already have a y prime on the right. So I will write those exactly as we see them. And then I have the one term that had a y prime on the left move over. It'll now be a negative by subtracting over. And I can now factor a y prime out of the right side. The left side will stay as is. And so we will factor a y prime out of the right side, leaving a 6y, the square root of x squared y squared plus 4, plus 2x cubed, the square root of x squared y squared plus 4, and then minus x squared y. To solve for y prime, we divide both sides by what's inside the parentheses on the right side. I will write the result up here, so I have room for it. And we have x y squared plus the square root of x squared y squared plus 4 minus 6 x squared y times the square root of x squared y squared plus 4 divided by 6y, the square root of x squared y squared plus 4 plus 2x cubed, the square root of x squared y squared plus 4, and then minus x squared y. It may be tempting to cancel out the square root of x squared y squared plus 4 from the numerator and denominator, but in order to do that, we have to be able to factor it out in the numerator, and there's one term that does not have it here, so it cannot factor out. And likewise, we have to be able to factor it in the denominator, and it does not factor out because there's one term down there that doesn't have it. And so they are stuck in the other two terms in the numerator and denominator, and there's no way to factor and cancel. So this is the simplified version of the derivative y prime.